Assalamualaikum and good day everyone. My name is Muhammad Arif bin Abdul Aziz. My matric number is 261927. I am final year student of Bachelor of Technology Management in University Utara Malaysia UUM. And the title of my final year research project is a feasibility study of solar energy implementation in Institute Utara Malaysia UUM. And my supervisor for this thesis is Dr. Shafini binti Shafi'i. Next, let me begin this presentation with the table of contents first. There are 6 parts of the presentation. The first one is introduction, followed by the problem of statement and the research objective. And for the fourth part is the research methodology, followed by the result, and lastly is the conclusion part. First, let me begin with the poster first. This is a glimpse of my final year research project. As can be seen in this poster, there is introduction, research question, research objective, methodology, result, and lastly conclusion. Next, Malaysia energy input in power station had relied extensively toward fossil fuels. The electrical energy has been the primary energy used by electrical equipment or energy stored in the electric current. Moreover, solar energy is an unlimited source of energy and its availability will never run out. This energy can also be used as an alternative energy that solar panels will be used to transform solar energy into the electrical energy. Solar energy is also generated from the sun's ray regardless fossil fuels are derived by the Earth's ancient carbon-rich excess. And eventually, solar energy will continue to exist as long as the sun keeps on shining. And Malaysia on the other hand is very potential in developing solar energy for daily uses. Malaysia, which is situated in the equatorial area and gets approximately 400 to 600 megajoules per square meter of solar radiation every month. Hence, it seems to be a potential location for large-scale solar energy installation in the future. However, there are many incentives provided for solar implementation through various attractive incentives provided through the SEDA Sustainability Energy Development Authority Malaysia scheme that provided by SEDA, which is photovoltaic system, can also be usually installed in homes and companies in Malaysia. And those incentives provided are such as Feed-in Tariff FIT and NEM Net Energy Metering Program. Moreover, Sinto is located in Kedah, where this area is a very potential area for the installation of solar system. This is because the area has a longer peak sun hour rate than other areas. It has been proven that solar implementation in university would be effective. The reason of this statement is that it was evident from the comparative simulation of analysis that UMP campus of Pekan and UMP campus of Gambang would be effective for photovoltaic power station commissioning. The expected high energy efficiency demonstrate the enormous solar energy potential on campus. It is also believed that the project will be feasible and has a positive rate of return. Thus, implementing solar energy in University Utara Malaysia UUM would be beneficial and worth the investment if UUM would opt for the solar energy as the primary source of energy in University Utara Malaysia. I will continue this presentation with the problem statement of this research. Electricity is indeed the fuel that the world needs, and the main issue is where it will come from to maintain it. Malaysia energy input in power plants has been heavily reliant on fossil fuels and will be depleted in the future if the consumer keeps consuming it as for now. However, energy efficiency and renewable energy have become more critical as they attempt to balance energy stability, sustainability, and equity, or more precisely, the energy trilemma in today's world. Malaysia has numerous potential of renewable energy sources that include solar, biofuel, hydropower, wind, geothermal, and tidal wave. Despite that, it is still in its early stages of growth to be implemented all this renewable energy. Moreover, in order to make UUM as a green campus, the implementation of solar energy is very suitable in ensuring that the effort is successful. This issue is consistent with the Sustainable Development Agenda 2030 and the Sustainable Development Goals SDG, since it helps to ensure that everybody has access to sustainable energy sources from the SDG 7 and ensuring fair, comprehensive, and continuous decent education from the SDG 4, and lastly, effective information and communication technologies, which is a component from SDG 9. Moving on to the research objective of this research. For this final year project, there are 2 objectives that has been identified, which is the first one is to evaluate the cost of solar energy implementation in UUM, and the second one is to evaluate the benefits of solar energy implementation in UUM. Moving forward to the research methodology. For this research, I have used the qualitative method to collect data to ensure that this research would be a success. From the qualitative method, there are two types of data collection, which is the first one is primary and the second one is secondary data collection. For the primary data collection, I have interviewed 3 persons, which is the first one is Mr. I.R. Razani Abdullah, the head of the Electrical Engineering Unit of JPP UUM, regarding the energy consumption and the cost of electricity in UUM. I had also an interview with Madam Nur Syuhadatul Amin, an architect in the architect unit of JPP UUM also, regarding the rooftop area of building that is very suitable for solar energy implementation in UUM. Moreover, I had also interview with Mr. Muhammad Nasrul Izwan, a senior business development executive of Detroit Energy, that provide information regarding solar components and solar costs as well as other relevant information. All these interviews has been done virtually using WebEx application. Furthermore, for the secondary data, I've also used the UUM library to access the past journals and study that is related with this research. I have also used the PV Watt website to generate the estimation of the total energy produced by the solar power in UUM. Moving on to the next part, which is the result of the study. 5 academic buildings that have been chosen based on rooftop factor, for which are STML and SQS, SMMTC, SFB, SBM and DKG buildings. However, a pro forma analysis have been formed and done to analyze all the data. Furthermore, the expected solar to be implemented in UUM with the incentive of NEM government, which could bring revenue towards UUM. Moreover as well, solar could be one of the effort of for UUM as moving towards a green campus and reduce the greenhouse effect, and also achieving net zero by the year of 2050. The table below shows the current electricity and annual consumption for each buildings. As can be concluded, the total annual electricity usage is 3,206,000 kW per hour, and the bill is 1,454,000 ringgit annually. A solar panel needs at least 9 meter per square for a solar panel to be implemented on the rooftop. However, for the grid connected system, the cost for each watt power would cost around 1 ringgit 30 cent, while the cost for grid connected system per 1 kilowatt hour would be around 1,300 ringgit, and the expected project lifetime would be around 20 years. However, all these costs listed are based on the current market values, and it might change as the market changes. Furthermore, this table explains the cost of solar panels by inserting all the required information such as the rooftop area, the size of panel, number of panels, the system size to get the result, which is the cost of panels, whereas a normal size panel produces 250 watts per hour, and I have also calculated the system size in kilowatt hour by multiplying the number of panels by 0.25 kilowatts per hour. And overall, the cost of panels for SQS and STML buildings would be around 163,475,000 ringgit Malaysia, and for the SMTC building is 183,325 ringgit thousand ringgit Malaysia, and for the SAFB, for the cost of panels would be around 265,850,000 ringgit Malaysia, and for SBM building is around 482,275,000 ringgit Malaysia, and lastly for DKG buildings would be around 888,225,000 ringgit Malaysia. Moving on to the total saving after the solar energy implementation. The overall total savings annually for all those buildings listed involved is around RM2,976,633 ringgit Malaysia, while the total saving for the term of 20 years for the total year of solar implementation is around RM30 million ringgit. And the total of this saving has included the total saving after the solar implementation as well as the revenue produced by the NEM incentive. Next is the benefits of solar energy implementation. Solar energy implementation will be a great effort in helping UUM moving towards a green campus university. This is because UUM has done many efforts in making sure that this will be a success, such as the application of electrical appliances stickers, the energy saving campaign that has been done through email, campaign and many more that has been done in making sure that awareness could be gained. As 2018, UUM has ranked on the 76th rank among the most sustainable university in the UI Green Metric World University Rankings, and on the extension of this success, UUM could be on the top ranking as the university implement the solar energy widely on the campus. And moreover, solar implementation could also be an advantage toward the cost reduction. This is because it's proven from the cost analysis that have been done before the solar implementation project could reduce the cost and at the same time could gain revenue towards UM itself. And furthermore, solar energy implementation would be advantage toward the environment as well. It is a significant concern for the world since carbon dioxide emission contribute to the greenhouse effect, which is very harmful to the environment. Thus, the solar PV installed on the rooftop will collect solar energy and transform it into a useful electricity ahead. And this technique does not consume fossil fuels or other dangerous substances, and no energy is going to wasted because it may be kept on the grid for the later use purpose. Furthermore, solar energy prevents water pollution since solar panels, unlike other industrial processes, do not require water to operate. In short, solar also could help lower down the building's carbon footprint. Finally, the conclusion of the research study. The total saving for all buildings expected will be around RM2,976,633 annually. Meanwhile, for the term of 20 years of solar term, it will be around RM30,077,180 ringgit. And this could be concluded that UM could save the cost and gain revenue at the same time by implementing solar energy with the incentive of NEM provided by SEDA. Furthermore, UM is very potential to be a green and eco-friendly campus after the solar implementation. And this is because the benefit of solar implementation in UM also could reduce the greenhouse effect, where the solar only produce and release quality energy for a better quality living ahead. And that is all for my final year project presentation. Thank you for your time and have a nice day ahead.